Hello everyone, I am Genesis Alas. I am a student of Prof. Ben under PRM 565.5, and for this video I will be talking about urban ecosystem. So we have to talk about cities first. So here are the things that comes into people's mind when being asked to describe cities. So cities are centers of commerce. Cities are hubs of transportation and communication system. Cities are wellsprings of culture and the arts, and cities are hosts of our greatest educational institutions. But there are people that when being asked about cities, this pollution, congestion, and urban decay are the first things that will enter their mind, which is we we can all agree about since these are all present and rampant to almost all of the cities. But I bet no one will ever say cities or ecosystems. Now, urbanization over the years. So, urbanization is one of the most significant changes over the centuries. So, urbanization, by the way, is a shift from rural areas to large cities. And cities became more numerous and much larger during the 19th century because of two trends. It's the immigration and industrialization. These two trends were momentous. People crowded together as never before, and they crowded into living conditions that were often squalid. In the 1800s, there were only 3% of the world's population that are living in urban areas. And in the 1900s, um, it increased to 14% of the world's population that are now living in urban areas. And there are 12 key cities that had populations over 1 million. And after 50 years, the world's urban population had doubled to 30%, and the number of cities over 1 million grew 6 times to 83 cities. Today, more than half of the world's population lives in urban areas, and it is predicted that by 2030 or 2030, almost two-thirds of the world's population is projected to live in urban areas. Rapid urbanization poses both opportunities and challenges, especially to poorer countries. Urban ecosystem and climate change. So eventually, all urban ecosystem will experience the effects of climate change. And additionally, many cities are located in geographic areas that are especially vulnerable to both existing and projected climate hazards such as coastal flooding, landslides, and extreme events. So climate change is impacting a very broad spectrum of urban ecosystem functions, biodiversity and ecosystem services. Increasing knowledge of the benefits of urban ecosystems for the livelihoods of urban residents suggests that an important and expanding role for urban ecosystems and biodiversity in adaptation to local effects of climate change. And urban areas all over the globe, especially in developing countries, are growing rapidly in both population and area and are putting pressure on urban biodiversity and ecosystems to support livability, sustainability, and climate resilience. Climate change and its impact on cities amplify the effects of urban stressors for ecosystems. So urban ecosystems are already under pressure, under general stress. We all know that from development, pollution, and direct human use. And climate change variability poses additional challenges for urban species and ecosystem. So there are studies that shows that there are ways to mitigate the effects of climate change to urban areas or to urban ecosystems. So the use of GIS and other holistic spatial planning tools and technologies in creating eco-cities and urban like green spaces will be of help in mitigating the effects of climate change. So, GIS consists of a proven set of tools that can provide information to leaders at the local and national level to facilitate evidence-driven decision making. It also it also allows us to move beyond 2D paper maps and incorporate everything that lies below, above, and around a city that create a 3D digital representation of the city's ecosystem. So building urban green infrastructure is also proven to mitigate or to lessen the effects of climate change to urban areas. So many cities have already made significant progress employing urban ecological resources for climate change adaptation and mitigation as part of urban infrastructure design, planning, and development. So UHI effect or urban heat island effect can be reduced by several degrees through enhanced transpiration and the shading provided by street trees, green roofs, and park. So the authors here had a research about mitigating urban heat island, and this is a real life example or real life plan. So in New York's Green Infrastructure Plan in 2010, it was this. It is designed to invest in new and restored green infrastructure for stormwater management instead of traditional gray infrastructure. So this included committing 1.5 billion US dollars of green infrastructure development for over the next 20 years. So green infrastructure refers to the natural systems including forests, floodplains, wetlands, and soils. So they provide additional benefits for human well-being, such as food, no, flood protection, and climate regulation. And meanwhile, gray infrastructure refers to structures such as dams, seawalls, roads, pipes, or water treatment plants. And there is also a Taizu plan. Taizu is a city located in China. So they developed a zoning plan that utilized green infrastructure to adapt urban growth to deal with potential impacts of climate change, including preventing stormwater-related floods and maintaining food production areas. So they incorporated ecological areas at multiple scales to maintain critical natural processes and flows, including hydrology and biodiversity, while simultaneously protecting cultural heritage sites and recreational areas. So we have here an example of a technology that is being used for urban planning and urban ecosystem management. So this is called Tree Detect or from Tree Detect. It is developed by Green City Watch. So Green City Watch leverage a combination of ecological engineering, machine learning techniques, and remote sensing methods known as geospatial AI to boost urban tree longevity. So the city of Boston work with an open source initiative. It is to use very high resolution satellite imagery. They use this platform to remotely detect the location of trees as well as view health indicators of those trees. So we can see here, this is the image from Green City Watch. So this is an overhead satellite image from part of Nubian Square. The green dots are the center of the tree here, as identified by the algorithm. And the red squares are the spread of the canopy. So as identified by the algorithm also. And the city of Boston said that they did this because one of their local nonprofits speak for the trees, has cataloged a third of Boston's public street trees. However, there remain barriers to getting a more timely and robust picture of the full urban tree canopy. So they have like they were curious to explore whether the use of a novel technology could help them do so, and they wanted to learn by doing. Now for the last slide, urban ecosystem in Region 8. So here in Region 8, we experience typhoons too often than compared to other regions in the Philippines, and climate change is one of the factors to be blamed for this. We are experiencing stronger typhoons compared before, and as I have mentioned earlier, urban areas like the city of Tacloban, and it is a categorized as highly urbanized city by the way, are most vulnerable to this type of calamities. There are intense flooding and many other hazards. And as I lived in Tacloban for more than 4 years, I noticed that there are still many trees around, but they are also endangered since we can observe that many lands are being converted into malls, hospitals, and roads, among others. But the main problem are flooding and mismanagement of solid wastes and garbages. So garbage are everywhere. For me, this is because there's a lack of urban planning and management, especially in the city. Um, so here is a picture that I got from the internet. There's just a few examples of garbages everywhere. So that's it. Thank you for watching.